Alright then, so we move on to the next elements of integration. So that now we're going to do integration of linear function raised to powers. So what is this and how do we go about with this? A linear function is placed in the form as f of x is equal to mx plus k, where m and k are what? Are constants. The rule for integrating a linear function raised to a power is given as, so this is how we go about with it. So summation or integration of mx plus k to the power n dx is equal to, so this m here you make as an inverse, so it's 1 over m multiplied by this same function, integrating it plus a constant. So let's do some examples for you to quickly understand. So you have example 1, which is integration of 3x plus 2 dx. So how do we go about with it? So it's simple and straightforward. So we just say is equal to, so integral. So whenever you have a root, square root, we said it's 3x plus 2 to the power t 1 over 2 dx, which is, so going by the formula here, it's 1 over 3 multiplied by 3x plus 2 to the power 1 over 2 plus 1 over 1 over 2 plus 1, which is equal to 1 over 3 multiplied by what's, okay, 3x plus 2. What's 1 over 2 plus 1? It's what? 3 over 2 over 3 over 2. So we can even simplify this expression. So how do we simplify this expression? We're just going to do this denominator, we're multiplying it with this numerator. So how do we multiply? Since this is a denominator, we interchange them. So it's 2 multiplied by 1, which is giving us what? Which is equal to 2 over 3 by 3, it's 9. 2 over 3, 3x plus 2, 3 over 2. You are done with question 1. Wait. Then we go to question 2. So how are we going to do about question 2? It's the same thing we have just done here. So it's integral. So this 5 will come here. 5. Then, in fact, the 5 will come outside here because of the integral. You cannot integrate a what? A constant like this. So it should be 6x plus 4 plus 3 rather to the power negative 4, which is equal to, so it's 5, then multiplied by what? 1 over 6, which is multiplied by 6x plus 3 to the power negative 4 plus 1 over negative 4 plus 1, which is equal to what? 5 multiplied by 1 over 6, it's 5 over 6 multiplied by 6x plus 3 to the power negative 4 plus 1 is negative 3 over negative 3. So how we do this? Okay, we just end here. Let's not waste time. But if you want, you can simplify it more further. Then now you go to our third and final example. So we have this simple question here. So you are integrating 1 over 8q plus 1 dq. So I forgot something, plus c here, even to the final answer plus c. Whenever you integrate, you always introduce a what? A constant. Now here, integrating 1 over 8, 1 over 8q plus 1. What are we getting? We said we are getting 1 over 8. So in this form here, we are going to introduce what we call natural logarithm. So it will be in 8q plus 1 plus the constants. Then you are done. So now let's write the answers now in a proper way. So let's do it like this. So our question one. So our question one was the integration of root of 3x plus 2 dx. So the answer we got was 2 over 9 open brackets 3x plus 2 the power 3 over 2 plus c. Then for question 2, the question was integration of 5 over 6x plus 3 power 4 dx is equal to, so it's c. So okay, here, so here you have a negative 3. So was it negative? Oh, we have positive, not negative. Oh, yeah, negative 3. So you have a negative 3. So negative 3, you're multiplying it with the 6. So negative 3 times 6, it's negative 18. So you have negative 5 over 18 open 6x plus 3 to the power negative 3 plus c. You go down now to the third one, which is integration of integral 1 over 8q plus 1 dq. This one was giving us 1 over 8 in hq plus 1 plus the constants. These are just the summary of our answers. Then we are done. Good morning, ladies and gentlemen. So we progress further in the integration. So today we're going to do integration by substitution. By substitution, you know what we mean, whereby you have a function, then you substitute in something else. In short, you introduce something else, but just to represent what you have, then you bring it back once again. So let's do some examples for you to fully understand. So we have example 1. So let's start with example 1. So example 1 says integral 5x plus 1 over 5x squared plus 2x plus 5 squared dx. So we have been now told to differentiate this function here by substitution method. So how do we go about it? So solutions. So we said number 1, which is integral 5x plus 1 over 5x squared plus 2x plus 5, then we square dx. So we'll just say let u equal to 5x squared plus 2x plus 5. So this what's inside here, we make it to be our u. Then now let's find what we call du over dx. So in short, the differentiation of this function, because this function is u, so it's du over dx, which is equal to integration of differentiation of 5x squared, it's 10x. Then integration of 2x, it's plus 2 here. Integration of 5, which is a constant, gives us a 0. So now our main aim here is to make dy over du over dx, or in fact dx, as the subject of the formula. So what do? We'll cross multiply here. So it will be du is equal to 10x plus 2 dx. Now here, as you can see, 2 and 10, they are what? They are common factors. So what can you do here? You can factorize the expression. So du is equal to 2. You factorize out a 2. Then here, factorizing 2 into 10, it's 5x plus 1 dx. Now we have to make what? Dx the subject of the formula. So we'll divide this both sides. So dx will be equal to du over 2 open brackets 5x plus 1. Then from here we are done. So now let's go back to the question. So in this question here, you have integral 5x plus 1 over 5x squared plus 2x plus 5. Then square it, dx. So we're just going to go back to this same equation. So in this same equation, we have here, we are just finding the value of this dx. So the value for this dx is what we have found here. So we're just going to input this where there's dx. So how do we go about with it? So it's integral 5x plus 1 over. Now, remember what we said. We said let u equal to 5x squared plus 2x plus 5. Now, here, so here, what's inside here, that's what we have said it would be our u. So it's u what? U squared here multiplied by, what's our dx? Our dx, we said it's du over 2 open brackets 5x plus 1. Now, as you can see here, on our denominator here, it's common with the numerator, which is this side here. So 5x plus 1 here and 5x plus 1 here will cancel. Therefore, you have 1 over u squared multiply. In fact, if you want, let's just do 1 over 2 u squared du. Then what follows here now? So we are now differentiating this function. So how do we differentiate here? So you just say integral. In fact, instead of it will be 1 over 2. 1 over 2. We said when you have a constant with a value of a function, you factorize out the function, so it will be 1 over 2 here integral. So u squared, since u squared is 1 over u, it will be u to the power negative 2. So du, then so it's 1 over 2 integral. So we now have to integrate our u to the power negative 1. So integrating it with u to the power negative 2 plus 1 over negative 2 plus 1. So our integral will go away since we have introduced integration here. So it's 1 over 2 multiplied by what? U. What's negative 2 plus 1? It's negative 1 over. What's negative 2 plus 1? It's negative 1 here as well. Therefore, it's negative. This negative will come here. So negative 1 over 2. So here it is u in negative 1. So it will be multiplied by 1 over u. Then our final answer will be negative 1 over 2 multiplied by 1 over. What did we say our u is? We said our u is, going back to the function, we said that u equal to 5x squared plus 2x plus 5. So even here where we are the u, we write 5x squared plus 2x plus 5. Then you are done. That's where we end from. That's what we call substitution method, because we have ever since we started, we have just been substituting. That's what we call substitution method. So we now go to our example 2. So our example 2, question 2 says 2, which is integration of 2x e x squared dx. So now we'll see again, let u equal to x squared. Now then differentiate. So we have to find now du over dx, which is equal to differentiating x squared, we will have what? 2x. Then we say du is equal to 2x dx. Then now making dx established the formula, it will be dx is equal to du over 2x. We are done here. Then we have to now go back to the same question we are given. So from the question here, it is equal to integral, it's 2x exponential x squared dx is equal to exponential 2x integral 2x, then exponential. Then we said let u equal to x squared. So here you have a u. Then on dx here, we have found dx to be du over 2x. Therefore, you will see that this 2x and this 2x will do what? Will cancel, which is equal to now integral exponential u du. So now here we're just doing what? Finding the integration of e exponential u. So how do we find it? Remember, by the rules of differentiation, we said whenever you are what? Integrating exponential u according to the standard results of integration we did, which was the first part. We said when you have exponential, it will be, each integration will be what? Exponential itself. So it's here you have it eu plus c. That's what we always get when we do this. Then we said our u is what? It's x squared, so it's exponential x squared plus c. Trying to differentiate this function, you find the same answer we have come from. When you differentiate this function, you go back to this function here. That's how it works. We are done with question example 2. Then we now go to our third and final question. So integral x squared open bracket 4x to the power 3 plus 5 to the power 20 dx. So I've been now told to integrate this function. So what are we going to do? We're going to say let our u equal to 4x squared, or 4x to the power 3 plus 5. This is our u. Then we find now du over dx. So du over dx is equal to, differentiating this function here, you have 12x squared. Then now we make dx there, establish the formula. So it's du is equal to 12x squared dx. Then dx is equal to du over 12x squared. From here you are done. Then you just go back now to the same question we were given, which was integral x squared open 4. Since we have said this should be equal to, okay, let's just write it like this, plus 5 the power 20 dx, which our integral x squared u power 20. When then dx, we said let it be, so this one will break it down into 1 over 12x squared du. Then here, as you can see now, you have x squared here, you have x squared here. These two can do what? You can cancel them. So it will be integral 1 over 12 u power 20 du. So which will be 1 over 12 integral u power 20 du. So it's 1 over 12. So now we have to integrate our what? 20e. So how do we integrate u to the power 20? It's u, okay, here u 20 plus 1 over 20 plus 1. So it's 1 over 12. Then new here, 20 plus 1 is 21 over 21 plus C. So here you're multiplying. Then it will be is equal to, so it's 1 over 12. So here you have multiplied by 1 over 21 multiplied by, what's our u? Our u, we said it's 4x to the power 3 plus 5 to the power 21. That's our u. Then which is equal to 1 times 1 here, it's 1 over, what's 12 times 12? Oh, 12 times 21. That's 12 times 21. 12 times 21. That's 252. You have 252. Then you have 4x power 3 plus 5 to the power 21. That's how the question ends. You have solved it. That's how simple these things are. Nothing complicated about integration. As long as you just know the standard results of integration and the rules of integration, you never go wrong.